Okay, so this is exactly what we were doing on the last problem. We were switching x and y, finding the inverse, and we expect that the inverse function is reflected across this line y equals x. And but the thing is here, it may be that we don't get an inverse function. I kind of suggested that last time, that in the problem set before this, that it's possible that we might not get, we'd get an inverse, but it wouldn't be a function. So the way to tell that is to check to see if it's one-to-one, also known as the horizontal line test. And if it only touches in one place, like this one here, then it's good. The inverse is a function. If it hits in two places, that's no good as far as it being a function. It's still the inverse, but it's just not an inverse function, okay? So, anyway, sorry for jumping that up there. So find the inverse of the function, then graph the function and its inverse. All right. So I have, first off, I have y is equal to x to the sixth. It doesn't say that, so I supply the y. And then I want to compare that with what happens when I switch. The x is equal to y to the sixth. And I take the square root. Well, that'd be something. The sixth root. I'm going to take the sixth root. Maybe I'll just write that below. I'm going to take the sixth root of both sides. Don't have room to squeeze it in there. And that's going to get me, what will it get me? Well, the sixth root of x. And let me switch it over to the other side. It's going to get me y is equal to the sixth root of x. Alright, so I gave myself a little bit more room here. And I'm going to say, what happens when x is equal to 0? Well, obviously y is 0. And what happens when x is equal to -1? Well, I get a positive 1 because that's an even exponent. And what happens when it's -2? Well, I get 64. 64. Well, that's a little out of my range. And the same thing happens with 1. I get a 1. What happens with 2? I get a 64. Can I draw that on here? No, it's just going to get really big, really fast. Because x to the 6th, it's taking off like a rocket. Okay, so 0, 0. And at 1, I've got 1. Well, that doesn't really forecast a whole lot. And then 2, I get about halfway there, so, okay. This guy's in a terrible hurry to get up as fast as possible. Okay, so there's my original function graphed. It's beautiful. And now, I guess I'll do it with the pink here. What happens here? Well, when x is equal to, say the same thing, it can't be negative. Oh, can't be negative. Could be interesting there. Because it's an even root. So if x is 0, then y is 0. And the sixth root, what shall we say? Well, obviously if x is 1, y is 1. And if x is, well, what's 2 to the 6th power? That's 64. I can't really show that. So, anyway, 64. And as I said, you can't put in negative numbers, so that creates a little bit of a difficulty here. So, I'm still going through 0, 0, and then I'm also going through 1, 1. And then I'm taking off here. I can almost get there. I'm past 40, but I still am not up to 2. Oh, that's a terrible attempt. Okay. And you can see that these guys are the mirror image across this guy right here. And this guy right here, they're mirror images across that line. But wait a minute, what about this guy? Where's his mirror image? Well, you say, Oh, you're looking for a mirror image. Well, let me do this for you. Let me come up with another column, and I'll say the sixth root of x. How about we say negative? How about that? And then that'll be equal to y. How about that? Well, now I'm going to get, if I do that, I won't have to make a very big chart. I've been making these huge charts for not much. And now just everything becomes negative. So if it's 64, I take the sixth root of 64, that's negative 2. Okay, so when I fill this out, or I attempt to fill this out, I still go 0, 0, and 1 gives me negative 1, and then negative 2 gets me way over here. Same kind of deal. Okay, and I don't know if you're keeping score there, but now this guy has his, that wasn't terribly well done, but he has his reflection now. This guy has his reflection over here, and that's nice, but we had to come up with a whole nother function. And what we could just say is, hey, you know what? When I draw a horizontal line through this function, it hits in 2 places. So it's not going to get its own inverse function. Sorry, it doesn't qualify. Doesn't qualify for that. So the horizontal line test would tell us that you might get part of something, but you won't get the full reflection unless you come up with another formula. And that's not really the same thing.